Okay, we are going to try an endothermic reaction now. So in Brett's left hand we have ammonium chloride, in Brett's right hand we have barium hydroxide. So these are both two white solids, and we're going to see what type of reaction we get when we mix these two chemicals together. So we're going to have a board, and the board, you might have noticed Brett put a little bit of water on that piece of wood. Okay, and then what we're going to do is we added the beaker on top, and we're going to mix our two white solids and see what type of reaction we get. Now, one of the white solids is called a hydrated compound, which means there's a water component in that compound. That would be barium hydroxide. So when the barium hydroxide undergoes a chemical reaction with the ammonium chloride, we get the water kind of being pulled out. Now, as Brett mixes the two chemicals, we'll start to notice that it starts to look like it gets a little bit thicker, and we get sort of a water component or solution component in that reaction. So as he's stirring it up here, you can definitely see that if I zoom in a little bit, that it's getting a little bit thick, a little bit milky colored. Okay. We're going to see if Brett can push some of that chemical down to the bottom, off the edges. Perfect. And we're going to keep on stirring it a bit. Notice that it's very, very liquidy now. We started with two solid compounds and we got a liquid. So this is sort of a rare chemical reaction that we have, where we have two solids creating a liquid, which is pretty nifty. Now Brett, what do you think? Is the reaction just about done? It doesn't look like it. It looks like it needs a little bit more time. So in this reaction, we have to do this in the fume hood because ammonia gas is a product of this, and obviously that's a harmful thing to be breathing in. So we're doing this reaction in the fume hood, and let's see if this reaction is complete here. Oh, look at that. So when we lift the beaker up, we notice that the beaker is frozen onto the board. Now that is because it is such an endothermic reaction. It requires energy that is from the environment, energy that is from the water. Now the water, again, since it's giving off that energy, it's endothermic reaction, and that water freezes. So if Brett is to try and pick the beaker off the board, kind of pry it off, okay, you'll notice quite a bit of effort to try and get it off there. It's pretty frozen on there.
Don't want to break it.
He's nervous to break it. Okay, we pry it off, and you can actually feel the ice. He can maybe chip some of that ice off with his finger.
Not with gloves on.
Not with gloves on. But there is ice stuck to the bottom of that. We can maybe see there. You can kind of see the ice stuck on the bottom there. So pretty cool reaction, very endothermic reaction that we have there. Excellent.